is our Professor James Ohlson. So Ohlson is our chair professor in accounting at PolyU. So he received his bachelor and master from University of Stockholm, MBA and PhD from UC Berkeley. So he has been taught at UC Berkeley, Columbia University, New York University, and Arizona State University prior to joining the PolyU. So Professor Ohlson has been the awardees of various distinguished recognitions, including the American Accounting Association, the AAA's Notable Contribution to Literature Award in 1995, the AAA's Educator of the Year Award, 1998, AAA's Wired Man Award, 1998, Changjiang Scholar, AAA's Award for Seminal Contribution to the Literature in 2013. And most recently, he was awarded the Member of the Accounting Hall of Fame 2015. So let's welcome Professor Ohlson.
So thank you very much here. Today I'm very lucky because I get to talk about my two favorite topics, how to deal with equity value and estimate equity value. And on the other hand, there's a question of how you do the data analysis. Having said that, however, this is my lucky day, but I really have to apologize in advance. I'm the third keynote speakers, and you have two very sophisticated talks. Mine is going to be so simple-minded, it's going to be close to embarrassing. So I do apologize in advance. Now, it turns out that there's an advantage here because my time has been cut short. So I'm going to have to do everything here now in 25 minutes. And I have very firm instructions. Do not use any time beyond 12:10. So I got to really try to deal with this little issue. But in any event, I think it's going to work out reasonably. So the talk here is going to be from a conceptual point of view and a practical point of view. So the nice aspect of this topic today is that it's very interesting in academic circles, but it's also very, very, very important in practice. Actually, it's sort of hard to underrate how important it is in practice. So what I will do is to sort of try to introduce all sorts of aspects that we have to deal with in the so-called real world. Whoops. This is a good start here. So let me run through this here now. And again, I apologize, this is very simple-minded. But the setting is fairly clear-cut. We want to estimate value, equity value. And the starting point here is, of course, going to be that you have a linear model. So this one seems to be fairly straightforward, but it actually involves many subtle issues, which we're going to have to talk about. First of all, when it comes to the dependent variable, you really have a choice between market cap and stock price per share. And this turns out to be actually in many ways quite important. Then we have the firm characteristics, and the firm characteristics may seem to be fairly obvious, but when you look at the literature, it easily gets very convoluted. But notice here that on the left-hand side, we have a dollar amount, and that means on the right-hand side, you also got to be consistent. That means that you got to have dollar amounts. You cannot put in anything else, at least unless you have a hard case to make. So we would expect here that the characteristics are current earnings, book value, sales, dividends, total assets, and perhaps even V at the beginning of the period. It's a dollar amount, and also we could include analyst forecast. So it's a fairly freewheeling environment. Backwards. All right. So this is sort of what I said here. Now, what comes out of this, of course, that after you estimated the equation, then you're going to have an error term. And then we talk about, and this is what we do in practice, we refer to this as a relative valuation error. And if you do this kind of analysis, basically what you expect, at least if you're reasonably sophisticated, that on the average there is 0, of course, and the magnitude, if you do a fairly good job, should be to the tune of 20%. So this is actually quite important. To what extent are we able to explain value? And what we like to think here, if we're good at it and there's a residual, then we found a map to heaven. In other words, we want to start to trade. So the idea here is that we have over and under valuation, so we can create a hedge portfolio, and then of course with some luck, maybe you can make money. Now I don't personally take this very seriously, but you actually can. But this is what people do in practice. So the issues that arise now here are twofold. On the one hand, what do you want to put on the right-hand side in terms of excess? But the second problem that's lurking in the background, how do you estimate the coefficients? And that's what today's topic is all about here. Man, 20 minutes to go. And I'm going backwards here. So this is sort of how it shows up in, no, I'm doing fine, I think. Well, out of the way. Okay. So this is sort of how it shows up in practice here, and I have to run through this with some speed. This is a newsletter. It's from investment banking across the harbor here. And so they come out with these newsletters, and this is all over the place here. And what they're trying to do is to convince their customers and their clients that we are very clever. We have clever staffs and we do clever things. And we understand academia here. So in this particular newsletter here, this is sort of how they write it up. And there's a paper, I think it's been published now, Bartram and Rindberg, 2015. And then they talk about what they're doing here. So they have a linear combination of the counting variables. It turns out to be something like 28. MCAP, B0. Now they're putting in an intercept here. And that's an issue that one should talk about, but time does not permit that. So then they run this here. No attempts to vain, they're very careful here. So this is sort of the usual thing that they try to convince that they're not overfitting and they're very clever. And follow our lead and we shall make you rich. All right. Now, so then it comes down to the brilliant idea that you have to buy undervalued stocks and sell overvalued companies, which is good to know. And the way we do that, of course, is that we look at the relative valuation error. So it's V hat, I, M cap, and then they have a right-hand side here. And that's sort of the estimated mispricing. So this is fairly straightforward. And in fact, much of the literature can be fitted into this kind of a framework, even though it's sometimes a little bit hidden. So that's fair enough here. And then, of course, I have to take the opportunity. They also refer to my work. And now the issue is that it's a question of what variables do you want to put on the right-hand side. And it turns out here now that what we did in this paper was to really use forecasted earnings. So you have analyst forecast, consensus, blah, blah, blah. And you can put in some other things here. And so this is sort of a little bit that you can go endlessly as to what you want to put on the right-hand side. And then again here, they go through the same iterations here. But they talk about the model, so there's sort of an issue of growth lurking in the background. Somewhere along the line, most people learn that in the so-called real world, growth is very important when it comes to valuation. So this is part of the modeling here. So this is sort of the idea that we find in practice here. And so they write extensively about this, and then they come up, of course, with something. This is what you want to do. And so you don't have to worry about the details here. So what we really end up doing is with a so-called screen. And the screen here tells you the undervalued stocks. And then they have a BG model, they have the OJ model, and they have the deciles, and forget about the colors there. And these are supposed to be the stocks that you're supposed to buy. Now, I haven't checked up if that actually worked, but that sort of idea here is fairly clear enough. Now, you can sort of laugh a little bit at this, but the problem, of course, is that you're going to have to come up with some suggestion how to do analysis better. Now, it also turns out here that, and I think this missed out here, that it also turns out that if you look at this newsletter, there's an extensive discussion about various estimation methods. And so this is sort of a little bit unknown, is that in practice, when you look at hedge funds and we do this kind of fundamental analysis, they actually do not use as much OLS as you might think. OLS is much more popular in academia than in the real world. And there's some investment banks actually down in the city, they've been using non-OLS for decades. So that's sort of like in the background here now. So we run into the second question. How do you want to estimate the coefficients? How do you want to do that? And then obviously, why not use OLS? Well, the sort of the why not answer is, why not use just OLS? I mean, that's sort of what people are trained to do. And as the saying goes, nobody ever gets a paper rejected because you use OLS. But you can get papers rejected if you don't use OLS. So why not use OLS? Well, it turns out that's very problematic. The first thing is now that you have the market value per share and you have the price per share. And then, so what you want to pick? OLS is going to come up with different answers depending upon how you pick the dependent variable. So market cap is not going to be the same thing as price per share. And now you have to keep in mind that in the background you cannot engage in statistical overfitting. So you have to make these decisions up front. Then, of course, we're going to have outliers too, and they are really nasty in this framework because you're going to have firms that are truly quite unique. You have takeover targets, you have companies with all sorts of problems that have not yet shown up in the financial records, and so there's much going on there. And then part of the story, of course, is that you're going to have an extremely severe case of heteroscedasticity. So now you may choose not to deal with that, or you may want to deal with it. But clearly, whatever you do, the answer is going to be very sensitive to how you do things. So how do you deal with it? You take total assets, price at the beginning of the period, or perhaps forget about scaling. There are all sorts of things you can do. That's actually discussed a little bit in the newsletter, that there are difficulties lurking in the background. But ultimately, of course, one can ask the really important question, why use OLS in the first place? And now it turns out that if one goes to the statistics literature, there are no known merits to OLS. OLS is a habit, and I will talk later, if time permits me, why the habit persists. It's certainly not based on logical grounds, but that's sort of lurking in the background here. So now you can sort of get a sense of where's the problem here. Well, we have to pick important variables on the right-hand side. And we have to avoid statistical overfitting. And if we want to avoid statistical overfitting, then we really have to end up doing OLS. Because if you want to start to use OLS, then the question is, which version of do you want to use it? Which dependent variable do you want to use? How do you want to deal with the scaling? How do you deal with outliers? There's a very large number of applications, and I sort of tend to refer to that what you really end up with is OLS plus. You have to do something else. So what is the solution? Well, this is the proposed remedy here. TS stands for the tile sand, and this approach has been around for 50 years, and again, I have very little time, so I have to proceed with some speed. TS is truly remarkable because it's unbelievably simple. And this is how it runs here. Some of you have seen this here, and it is. So here's what you do. Pick three, if you suppose you have, just for the sake of argument, 3 variables on the right-hand side. So what you do now is you pick 3 firms at random, you calculate A, B, C. It's a 3-by-3 equation system, but it really reduces to running an OLS with 0 degrees of freedom. So it's the same thing. I think most people understand that. And then you can repeat this procedure 100,000 times or even more, whatever have you, and then you just pick the medians. Now you are done. This is it. Now, there is some fine print in the background here, but again, the time does not allow me to talk about it. But it really is very straightforward. And you also notice here there's absolutely no optimization going on. It really is in the spirit of bounded rationality, if you wish. You sort of see how do things work on average. And this is what you do. The question now arises here, who likes this? And it's sort of an interesting question. I was thinking about yesterday when we had the presentations about, what was it, superstition. Maybe you have to be superstitious. But then it occurred to me, a guy was bringing in the notion of cognitive limitations, or cognitive deficiencies. And this is sort of really the nice thing with this, that you can be quite stupid and you can do it. But that then has the problem that if you start to do this, you may seem to be stupid, because it's so much less sophisticated than OLS. Anyone can do this here, and so you can try it out here. Now the question arises, what are the virtues of this? And that really gets to the heart of it. Why would you do this rather than OLS? Now keep in mind here, OLS really has no known virtues. There are no known virtues in statistics due to OLS.
I thought that you learned that OLS was blue, that they made us memorize that in conventions.
Yeah, they're blue, but that's sort of, is that a virtue?
That's linear up on it.
Yeah, I don't know why linear would be so long before. But here are the advantages, and with TS. And you sort of have to pay a little bit of attention here, because I'm actually going to say, to the extent I'm saying something important, it's going to come here now. The first advantage here, and I should notice here that this exists in the literature, and the TS is not used in the social sciences, but it's extensively used in the sciences, biology and so forth. But again, that's sort of the science here. The first thing here is that estimates are robust, they're very robust relative to outliers. So, you know, this procedure of trimming and scaling and all of that stuff, trimming and winsorization or whatever you do, don't worry, it will not make any difference. It's very peculiar OLS because you're supposed to, the OLS emphasizes outliers, and then you turn around and you have to winsorize outliers, or you have to trim outliers. The TS is 1 over n, everything is equal. So if you start to trim or winsorize, you're really changing very little of the information set. Whereas that's very different from OLS. Again, if I have time, I can sort of elaborate on this here, but I have to go with some speed here. The second thing is don't worry about scaling, because you're going to get exactly the same results. Your arms are tied. Scaling do not change things. And the reason that happens is it's really like, again, it's just linear algebra. So if you divide the left-hand side or right-hand side, you get the same thing. If you use V or P, you get the same thing. You just rescale everything. Scaling does not count. We have no outliers. We have no inliers. All observations are 1 over n. So scaling does not count. This is really quite remarkable. If you do this in a panel situation, what happens is that you're pretty much going to get the same results every year. And this is quite remarkable experience, because if you use OLS and you use panel data and you estimate the equation for each and every year, numbers jump around. OLS estimates jump around compared to TS estimates. Now we get down to something here which makes people a little bit uncomfortable. So it really is that if you start to do simulations, and you can do that in an afternoon, and if you are curious, you might even think about doing it. It's very easy to do. So you can simulate, you have a true model, you generate x's, you generate epsilons, you know what the true values are, and then you can check out who is winning. And the answer is, if you have a little bit wide x's, a little bit wide epsilons, you're going to find that again and again, the conclusion has to be if you take TS and you add a little bit of noise, you end up with over less. So that's sort of the conclusion. Now, again, one can sort of introduce a little bit of drama here. Again, there's sort of theory on this stuff, and there are all sorts of things going on, so I'm sort of oversimplifying here. The theory, to be absolutely sure, and Mike in some sense implicitly raised the point, is that if in fact you have ideal conditions for over less, you're going to find that TS and over less pretty much end up doing the same thing. So if you have non-ideal conditions, then what happens is you can do TS, you can add a little bit of noise, and you end up with one or less. So that's sort of really the thrust of all of this analysis here. And that then raises the question here, sort of how things really work, and it's kind of difficult to explain. But let me then just come back here to that Barton and Grindlach, they looked at this very carefully within their framework. And I'm going to run through this very quickly. But this is sort of important, because what they do is to try both over less and TS, and then they use the undervaluation, relative valuation error there, and then they construct their portfolios. And throughout the paper, you know, you get the results from this pricing are stronger when the signal is based on TS estimation. Oops. And again, so these are the quotes. The TS signals have Sharpe ratios of up to 1.55. That's actually quite high. And for signals from TLSM regressions, all spreads economics and statistically even more significant, ranging from 71 basis points. So I just give you a sense of the flavor of the paper that has looked at this experiment fairly carefully. This is an extensive paper, and the conclusions is that if you want to play the game of picking up undervaluation and overvaluation, TS is going to give you the better estimates. So this is sort of what we find here. Now, finally here, if you're with me so far, we're doing something simpler that seems to be much more efficient, and it generates a little bit of discomfort. And so the final thing I'm going to try to do here is to explain why does this happen actually. Well, one approach, one way of answering the question is that OLS is so deficient that I don't really have a fair competitor, and this is actually some of the critique you get against TS. Don't compare with OLS. Try to find something like medium, you know, all these other competing estimation schemes, because after all, OLS really has no virtues aside from giving you overstated T statistics. Now, so let me try to explain this here, how this works. And again here, 5 minutes here. One slide. Let's see how this works here. You see, the essence of OLS, it gives you the typical relation. So ask yourself, what should be the typical relation? The data will support you. The data will support you. So use your common sense and try to think about what the typical relation ought to be, and then we're going to do pretty okay. So here's a very simple version here. V1 now is EPS1, which is forecasted earnings times a market multiple, and V2 is EPS2, so it's earnings 2 years down the line as expected by the analyst times its market multiple. So we have a valuation model here, right? And so we have two valuation heuristics, V1 and V2, and then we try to combine that to explain the intrinsic value. So this is roughly how we do it in the real world as a first cut. You look at forecasted earnings, you take a market multiple, and then it gives you an estimate of value, and you sort of this kind of equation, you end up with something like 20% in error. It's a fairly small error. Now, what should V1 and V2 now equal? Now I'm going to get into trouble. One thing is, of course, that A1 plus A2 ought to add up to 1, because you have two unbiased ways of looking at value, so the coefficient should add up to 1. Now, as a typical relation, how about? So you have, in the typical case, you have no errors, you have p hat. And then you take V1, and then you take an average, and then you get V2. The idea is that p hat is the best you can do, V1 is the worst you can do, and probably what's missing is V2, and being in a bounded rationality world, we should probably take half-half. This actually sort of is a way of thinking about it. You can try it out, and that suggests that you should end up with A1 equal to -1 and A2 equal to 2. So the idea here is that if you think about the real world, and if you think about the PS2, it's sort of a complement to near-term earnings and the current value. And you would expect that the way to do this within insufficient reason bounded rationality, V2, the estimated value looking 2 years ahead, is probably just an average of what's missing here. So that's sort of the reasoning here. Now what you can do, of course, is you can estimate this model, right? We get back to the first slide. This model can be estimated. And now you can estimate this one using TS, and there's only one way of doing that. You can also estimate it uses OLS, but then you have 5 different ways of doing it, because you have to deal with heteroscedasticity, 1, 2, 3 possibilities. You can maybe divide by total assets. You may forget about heteroscedasticity. So you get OLS plus. Results depend upon which version of OLS do you use. The catch with TS, there's only one way of doing it. Your arms are tied. And that may make you uncomfortable, because you get what you get, you have to live with it. And that gives me, right on time, the final slate. So this is sort of a different paper here. So what do you get here? Well, you get exactly what you should get. You don't get that if you use versions of OLS. Because of OLS, you have all the outliers and I'm going to give you trouble. However, if I do start to trim and I play around with OLS, I can get close to this. But I'm not going to waste my time. If I have something simpler that gets me to what I expect to get, I, for one, would use what's simpler, even though it may seem a little bit cognitive limited. So here now what you get here is really quite remarkable in some ways. It's actually not once you get used to it. Minus 0.95, so if you look at the two sums, they add up to 1. Pretty close each and every year. You have to make your own judgment. And then, of course, if you look at the coefficients here, they are negative on the first one and positive on the second one, which is precisely what you should expect. This really is what we call growth in practice. Growth in earnings is a driver of the PE ratio. And this is really just what you're picking up. But you're picking up the natural benchmark. There's really no other way of thinking about what you want to get as a starting point. But in any event, if you want to put in numbers here, you get fairly good, close to actual values on this approach. It's not as if you're out there. You know, the errors are sort of 16, 17%. If you can come up with something better, let me know. I think that will be require some thinking. It can be done. So that's sort of the end of my story here. Man, do I have 2 minutes? I want some concluding remarks. So, because I thought about my concluding remarks. So again, I apologize for having been so simple-minded here. Now I'm going to become even more simple-minded. So here's the fourth experiment. Suppose you never ever heard about OLS. And for 30 years, all we've been doing is TS. So you can imagine we have a long history of doing TS. And then suddenly I show up here today. I'm talking about OLS. And then I'm going to say, oh, OLS is brilliant. It's blue. You get these things. And you get this and that. And then probably say, what's going on here? How do you deal with outliers? Oh, well, we're going to trim or we're going to windsorize. And I think if I answered that, people would actually start to laugh. because on the face of it, it's so obviously stupid. Having said that, however, there might be one smart person in the room which would see an opportunity in OLS. What is the opportunity in OLS? The answer is you get to try many different versions of it, and you're also guaranteed to get overstated statistics. Incentives in the publication games, you want to validate your story. If you want to start to use TES, I have bad news for you. Your arms are tied. And it also turns out that if you start to simulate it, if you have the true model has a 0, the estimated model is very bad. It confirms it shouldn't be there. Now that clearly runs counter to our world of publications. Even if something is not important in the explaining the dependent variables, you want to scramble and come in with lots of noise, so somewhere along the line in this noise, you can pick the screen that gives you the conclusion you want. So that's sort of, in some sense, the bottom line. If, in fact, statistical overfitting is unacceptable, then what's going to happen is a little bit what happens in investment banking. You're not going to do OLS. There are too many versions, too many overstated t-statistics. We don't look at t-statistics anyhow, because you really have to deal with validation of the model. So that's sort of my final comment here, very rushed here. But I think that, that you really shouldn't listen to me, except in one regard. If you really happen to be interested, you should spend the afternoon it takes and simulate. It takes an afternoon to simulate, and after you start to do the programming, after you start to do it, after a while you're going to say, of course it works better. What do you expect? So it sort of seems a little bit like a waste of time. So that's sort of my final punch, that if you have an interest in it, don't listen to anyone, don't look at any theory papers, spend the time and just do some simulations, and then you arrive at your own judgment. Does it work better or not? Well, look at your experience in front of the screen when you simulate it. So, really sorry, too much time. Thank you.